Hi everyone, welcome back to our channel. Today we are going to discuss a classic problem in programming, that is how to check a prime number, how to check if a number is a prime number. So, alright, let's discuss first what is a prime number. So, what exactly a prime number is? The prime number is a number that is greater than 1, and it has only two divisors. That too, it has only two divisors, that too 1 and itself n. N is a number we are supposed to take. So it has only two divisors, the two 1 and n only. So if a number has more than two divisors, it can't be a prime number. So let's prime number be n. So it can't be a prime number. So understand, if it has divisors less than two, then also it can't be a prime number. So understand? Just just remember this. It can't be if it has divisors greater than if it has divisors more than two, it can't be a prime number. If it has divisors less than two, it can't be a prime number. So a prime number has only two divisors, that two one and the number itself only. So understand? So let's write the program. So we are taking an integer variable n to store the prime number, to store the any number. So first we print enter the prime number, enter the number. So enter the number. Then we store it in n. So cout is used for printing any statement, and cin is used to store a number or any variable. So we are going to write the first condition. So if n is less than or equal to 1, because if why are taking n is less than or equal to 1, because 1 cannot be a prime number, because it has only one divisor. It has only one divisor. That is, let me explain here only. That is, 1 is divided by 1 and a number itself, that is 1 only. So the total divisors is 1. So as we discussed that prime number has only two divisors. So 1 cannot be a divisor, and the 0 cannot be a prime number, and negative numbers can be a prime number only. Okay, understand? So the number that are less than or equal to 1 are not a prime numbers. So directly we print cout n is not a prime number. That is not a prime number. If this condition doesn't satisfy, we write other condition. So here we are taking for loop for I is equal to 2. Here starting from 2, I is equal to 2. I is less than square root of n. Here sqrt is the function to find the square root of a given number. We will discuss this in later. So why we are taking a square root? So let me explain. So first complete this. So let me explain here. So first close this. Okay. Let me explain here. Okay. So why are taking square root here? So let me explain with an example. Take 16. So what are the divisors of 16? 1. 16 can be divided by 1, 2, and it can be divided by 4, 8 also, and 16 also. So total 5 divisors. So what is the square root of 16? So square root of 16 is 4. So see here 4. So the number 2 is less than 4. So 2 is also a divisor of 16, and 8 also a divisor of 16. So from the above we can conclude that the number if we have any divisor greater than its square root, then we can also have a divisor lesser than the square root. That means the lesser than we have 2 as a divisor, and greater than square root we have 8 as a divisor. So you are understanding now? Let me explain it again. 16, it has 5 divisors, that is 1, 2, 4, 8 and 16. So what is the square root of 16? That is 4. So the number, if 8 is the divisor of 16, it is greater than 4 square root, greater than the square root of 16, that is 4. And 2 is also a divisor of 16, that is less than the square root of 16, that is 4. So if it has a divisor greater than its square root, it must have a divisor lesser than its square root. So that's why here we are taking the square root, because to reduce the time complexity. So if we run from 1 to and 16, 2 to 16, it take a lot of time. If we reduce the steps, so we can easily get the answer here only. So we print. So now if n percentage by I is equal to 0, if n is divided by any number, then we print Cout is a prime number, is not a prime number, is not a prime number. And we break we break the loop here only, we discontinue and we came out and return 0. We terminate the program. Otherwise, if we can't, if any number cannot, if n is not divided by any number, then after completion, this while loop, this while loop run for up to a root, up to square root of n, and if it cannot divided by any number, then it will come out of from the square root loop, come out of from the loop, and we print Cout is a prime number. So we can't find. So here we are finding that the given number is not a prime number. We are proving that here we are proving that the given number is not a prime number. So once we conclude that the given number is not a prime number, then we can print it is a prime number only. Okay, understand? So this is the program. So first we take an variable n, and we store the prime number integer into the n, and we are writing the first statement, that is n is less than or equal to 1. If n is less than or equal to 1, we print the given number is not a prime number. And the second condition is, if any number divides the given number, then it is not a prime number. So understand? And then if it does not divide, if any number doesn't divide n, then we print the prime number, the given number is a prime number. So let's execute this program. First save the program. Okay. Then execute, compile the program. Right. Enter the number. Let enter 2. So 2 is a prime number. Here we see it is given 2 is a prime number. Let enter the 16. So 16. So 16 is not a prime number. Okay, let me see. Okay, wait. There's something.